This last section might seem out of place, but it still deals with binomials. And let me get the idea down for you, and then I can show you something pretty cool. So this, when they ask you to expand each one of these binomials, notice why they call it a binomial. I mean, that's exactly what this is. But think about anything to the 0 power will equal 1. Anything to the first power is equal to itself. And then this next one, just think about it. If I asked you to FOIL that out, you know, x plus y times x plus y, what you end up with is, as you do the outside and inside terms, not just x squared and y squared, but there's 2xy. Now there's this neat little thing that will actually help you do these problems pretty quickly. The thought process, and I'm not going to do this, because if I ask you to take something to the third power, well, basically what it is x plus y times itself 3 times, which is why they say use your answer for x plus y squared, because instead of writing out x plus y times x plus y times x plus y 3 times, you can only do 2 at a time and then do it again. I'm just going to show you the answer, that x plus y cubed is equal to x cubed plus 3x squared y plus 3xy squared, and then plus y cubed. It's a neat pattern, and it's based off of, I'm just going to put it right here, what is called Pascal's triangle. It's named after somebody named Pascal, so it's not just a made-up thing. But anyway, what it is you write down ones on the outside, and I'm about to give you what happens on the inside. You might want to hit pause in the video, see if you can come up with the pattern here. Because I'm going to just tell you, you take the sum of the previous 2 numbers. 1 plus 4 gives me 5. 4 plus 6 gives me 10. 10, 5. So you might want to try it again on the next one. 6, 15, 20, 15, and 6. And the other piece that they're trying to get you to notice is what happens to the powers of x. Well, if you notice, we start with x to the third, is they decrease by 1 each time. So you see how we start with 3? And then what about the, and you could write on this one, you could write x to the 0 power, couldn't you? Because x to the 0 power is equal to 1, x to the first. And then the same thing with the y's, the powers increase by 1, and this time you're starting at 0. And I'm not sure if you noticed, so let me point it out. When you have the third power, you go to the third row for the coefficients. 1, 3, 3, 1. And at any given point, let's finish this. Oops, I need to be on my pen. The sum of the powers, well, the sum means add, so they add to equal the power that we have. So in this case is 3. To equal 3 in that specific case. So instead of showing you the binomial expansion, I'm going to try to stick with Pascal's triangle. So if you need to, rewrite Pascal's triangle, and I hope you can do it without my help. So right here is to the 4th power. Those would be your coefficients. You don't have to write down the 1. You can just write down x to the 4th. But there's an implied 1 in front. But then after that, it would be 4x cubed, because we have to decrease the exponent by 1, and then y to the 1st. Then the next coefficient will be 6x squared, because we're decreasing by 1, and I have to increase the y by 1. And then 4xy cubed, and then y to the 4th. And this is actually something that we use in calculus, and notice that you don't have to write 1 in front of this. So let's go to the next row in Pascal's triangle. 1, 5, 10, 10, 5, 1. So this answer will be x to the 5th, 5x to the 4th y, 10x to the 3rd y squared, 10x squared y to the 3rd, 5xy to the 4th, and then 1, which you don't have to write down, y to the 5th. And that's the thing that's sort of interesting about this with Pascal's triangle. So let me just point out right here. What you can do is you can notice that, well, I should mention a few other things, and I'll probably teach more in class. We actually call this row 0 right here. And there's a reason for it, is because you can actually count the rows by these numbers. So in Pascal's triangle, we would call this number right here 5 combination 0, 1, 2. And if I go to my calculator, just to show you real quick, 5 combination 2 is equal to that entry. And if you don't believe me, like, think about how this element right here would be 15, and it would be 6 combination 2. And you can find any element in Pascal's triangle is a combination. So if any of you are curious, I could teach it using a binomial expansion. I just kind of prefer Pascal's triangle. So how do we make it a little bit more complicated? Is instead of just x's and y's, we throw out some different numbers in here. So what I like to do, and it would actually be to your benefit to practice Pascal's triangle, but I know I'm on this row because of the 4th power. And so those are my, let me just write it out, spaced out, 1, 4, 6, 4, 1. Now what's different here is the first element isn't x, it's 2x, but it's to the 4th, and then 2x to the 3rd, and 2x squared, 2x to the 1st. And then this isn't just y, it's negative 1 to the 4th, negative 1 to the 3rd. And there's actually a pattern here, if anybody wants to memorize it, that anytime you have a negative, you alternate signs. And just remember the order of operations. Alternate signs, how about that? There we go. Is to make sure you do the exponent before multiplying. So 2 to the 4th, 2, 4, 8, 16, x to the 4th. Do 2 to the 3rd next, which would be 8 times 4 is 32, times negative 1 would be negative 32x cubed. Now remember, when you square a negative, it becomes a positive. That's why you alternate signs. 2 to the 2nd power is 4 times 6 would be 24. Negative 1 to the 3rd power, that's going to be a negative. 4 times 2 is 8. And then negative 1 to the 4th would be a positive. There's your correct answer. And what they wanted you to do is show by using a calculator that you have the right answer. You can go to y equals. I think we've done enough of these equivalencies to show you. If this answer really is correct, what will happen is, in the table, every answer that we get should match up. So hopefully I typed that in correctly, and I can just go to the second graph and look at the table and see that all the y values match up no matter what. So that's a quick way you could check that you have the right answer, and we do. Now sometimes they don't ask you for all of the entries. They only ask for, say, the 3rd term. That's where the binomial theorem could be your friend, because maybe you don't want to go to Pascal's triangle. I'll write PT for Pascal's triangle all the way down to the 6th row. If you've already written it, which we did, I think we wrote the 6th row somewhere, we could, right here, we could get to the 3rd entry. It's 15. Otherwise, that's why it might be beneficial to know the binomial theorem of doing 6c. Now, here's the other thing that confuses students, is if you're doing the binomial theorem, you actually start with 0, So the third term is actually 2. And then it would be 3x, the first term, because it would be to the 6th power, to the 5th power, to the 4th power. And then the second term, 2y, would be then to the 2nd power. But if that confuses you, I would go ahead and write out Pascal's triangle, where we have 15 times 3x to the 4th power times 2y to the 2nd power. And feel free to write down any of your questions. But at the very least, I hope you would be convinced that 1 and 2 are incorrect because they have the wrong exponents. I guess what I'm saying is I hope you could start by writing out that the first term would be x to the 6th, the next one would be x to the 5th, y, and then the next term, the third term, what we actually want, would be x to the 4th, y squared. But either way, at this point, you can go to a calculator, quit out of that, and you could do, well, I wrote it right here, 6c2, which is 15, times 3 to the 4th, times 2 squared. And you get the right 4860. Just a couple more problems. And this time they want the middle term. So the middle term on the 8th row, see, this would be a time where maybe the Pascal's triangle is not useful, but it is row 8. And the middle term would be x to the 4th, this one to the 4th, this term to the 4th. So that's why it's going to be 2x to the 4th and -3 to the 4th. So that's where using your calculator would probably be your friend. I probably need that multiplication in there, don't I? Let me insert a multiplication. I've never actually tried without a multiplication. And now it is important that you put the -3 in parentheses, because when you take 4 negatives, you get back to a positive. So it should be that 9072. It's 90,720. I don't know why I said that so wrong. And here's another one where they just want the last term. So the last term, I think you've probably noticed that the last term always ends with a 1 as the leading coefficient. The 3x will be to the 0 power, and that -2y will be to the 6th power. But you could do, 6c, the 6, the very last, which would actually be the 7th term. But anything to the 0 power will equal 1. So you really just have to know that -2 to the 6th power, as you type it into the calculator, will give you a positive 64. Try to save some time here. And then which represents the exponent only on this second term in this expansion. So you have to think critically about the exponents, all they really care about. But remember, it starts with x to the 4th, and then the next one would be x cubed. Now here's the thing, is the first term isn't x to the 4th. So let me cross that off for a second. It would have been x squared to the 4th, and then the next one would have been x squared cube. But then you also have to consider that -1 over x is to the 1st power. So think about it, and recall that a power to a power, we have to multiply those exponents. So we're looking at x to the 6th, and then really what we have is dividing by a -x. I don't really care that's negative, but there you go. And so you'd have to subtract those exponents. So it'd take me to the 5th power. And hopefully that made sense. If not, please write down your questions, bring them to class, and you should be ready for the last homework assignment.